Alright, let's take a look at some more problems involving rational expressions. One of the keys here, of course, is always going to be to factor these expressions and then cancel. And really, a lot of times also you'll want to clear the fraction. Those are some key things that I'm going to be talking about as I do some problems. First of all, let's factor this. I'll just write it directly above it. That's going to 5 is going to factor out of that. So that's going to be x squared minus 125. Let's see, there's 20 and 5, 25, which is good because now I still have a difference of perfect squares. So let me just erase that, and I'm going to write that as x plus 5, x minus 5. And it's a good thing too, because on the bottom here, when I take a 10 out, it's going to leave an x plus 5 here. So before I do anything else, I'm going to cancel out the common factors there. Now if I'm dividing that by x minus 5, that's like x minus 5 over 1, and dividing by x minus 5 over 1 is the same as multiplying by, I shouldn't write x, I should write a dot, multiplying by 1 over x minus 5. So there's my new problem, and notice what I can do now is I can cancel, since there's 1 on the top and 1 on the bottom, I can cancel those out. The 5 and the 10 have a common factor of 5. I can cancel that out. So on the top I'm left with no factors. Don't leave it blank. It means there's a 1 on the top. And on the bottom I'm left with just 2 because everything else canceled out. So here's your answer, 1/2. Let's try another problem. This is different because this says minus, so this is not multiplying or dividing. It's subtracting. And whenever you're adding or subtracting fractions, you need a common denominator. So I'm going to first factor this so I can see what my common denominator is. Notice that this has an x plus 1 and an x minus 1. This only has x minus 1. That means I have to get a common denominator of x minus 1, x plus 1, which means I have to multiply this second fraction by x plus 1 over x plus 1. That will allow me to rewrite my entire problem with my common denominator of x plus 1, x minus 1. And of course, in this case I don't actually need to factor this because all I would be doing is multiplying it back out because I want to get common denominators in the top. But here's the other trick with this one. Many people make a mistake because they forget about this negative right here. So when I take this and multiply it out, so let me just write the 2x squared plus x plus 3. That was this right here. And then I'm going to write minus and use parentheses here. Don't forget the parentheses, and I'm going to FOIL this out. X squared, that's going to be plus 2x and plus 1x, so that's plus 3x plus 2. Now I'm going to distribute this negative in. I'll do that in green. And I'm going to add like terms. So my final answer is 2x squared minus x squared is x squared. X minus 3x is negative 2x. 3 minus 2 is positive 1 all over x plus 1, x minus 1. But I'm not done because now I can factor what I have at the end. I can factor this into, I'll just do this right here, x minus 1 times x minus 1. And now I can cancel the x minus 1, and I'm left just with an x minus 1 on top and an x plus 1 on the bottom. One thing you can do to check it is you can take every time you see an x and you can plug in a number. Sometimes 0 is good to work, sometimes 1 or negative 1 or 2 are good to work. Plug in this case, let's plug in 0 everywhere there, and plug in 0 everywhere you see an x up here at the very original, and see if your answer is correct or the same on both of them. So if I plugged in 0 here and here, I would get negative 1. If I plugged in 0, 0, 0, 0, 0, 0, 0, I would get negative 3 here, and I would get, let's see, what would this be? Minus, this would be 2 times 1, which is 2, all over negative 1. So minus negative 2 and minus a negative is plus a positive, and what's negative 3 plus 2? Negative 1, and that just checks your answer to make sure that you did it correct. So what is your correct answer again? It's x minus 1 over x plus 1. X minus 1 over x plus 1, and you know you did it right because you checked it. Let's try one more. Now this is a different problem. This is a complex fraction, and the trick with this is to clear the fraction. Actually, we're going to do another one after this as well. So the first thing I'm going to do is I'm going to find the least common denominator of all of my little fractions in here. Notice that there's only one fraction, and the only denominator is 3. So if I multiply everything by 3 on the top and bottom, watch what happens when I do this. I'm going to get, remember I have to distribute that in. On the top, the 3's are going to cancel on that first term. I'm going to get x minus 3 because I have to multiply that in. And on the bottom, I'm going to get 3x. Actually, you know what? Let's not even multiply it through on the bottom. Let's just leave it 3 times x minus 3, because you'll see what's going to happen now. These cancel, and my answer is just 1 over 3. Let's try one more. What's the least common denominator here? You can see that it's x. So if I multiply the top and the bottom by x, again I'm going to distribute it in. I'm going to get 3x plus 1 on the top, and on the bottom I'm going to get 4x minus 1. And there's nothing I can do to this to simplify it, so I'm done. Let's check our answer, make sure it's right. Let's pick 0 and plug in 0 everywhere here. That's going to equal negative 1. And if I plug in, well, bad example. I can't plug in 0 because 0 wouldn't work in this first equation. So let's choose something else. That's where you have to be careful when you're checking your answer. You can't just pick anything. You have to pick something that's not going to cause a problem. So let's pick 1. Let's put 1 everywhere, everywhere we see x. And what am I going to get? On the right side, I'm going to get 4 over 3. And on the left side, I'm going to get 3 plus 1 over 4 minus 1, which is 4 over 3. And look at that. They equal each other. So it checks out. We know we did it correct. So there's a few more examples. Good luck. Watch the video again to get some more practice if you need it.